Okay, geometry kids. I don't have my regular document camera that I usually record on because I wasn't planning on being gone. I've just got a kid that's decided to get the flu. So I'm gonna go through notes just really fast as best I can for you, and we'll fix anything that needs fixing tomorrow. So you should have two pieces of paper for for notes. The first one's 6-2, and then the other one is a grid that kind of looks like this. We're going to fill in this first one, this top corner over here, and I've already got the notes kind of typed in for you because I can't write on anything on here. So 6-2 is parallelograms, and I want you to go ahead and draw a picture of kind of what a parallelogram looks like. Usually you just have the slanted edges, and then the top and bottom are completely horizontal. That's the best representation of a parallelogram that you can draw. There are some interesting things about parallelograms that we write down, and I just have them numbered 1, 2, 3, 4, 5. So there's two interesting things about the sides. First of all, the sides that are opposite each other are congruent. So this bottom side is exactly the same length as this one, and the same with these two. The two sides are exactly the same length as well. Not only that, but they are parallel to each other. So this is parallel to that, and this one's parallel to that one. Has to be that way, otherwise it's not a parallelogram. Angles, the opposite angles. So this one here and this one here would have to be exactly the same measure. So if this one's 40 degrees, this one's also 40. Same thing with this one. This one would have to be the same measure as that one. And then the consecutive angles are supplementary. Consecutive means ones that are right next to each other. So I'm talking about like this angle here and this angle here. Those two would have to add up to be 180 degrees. Okay, now these two are consecutive, but also this one is consecutive with this one. So these bottom two would have to add up to be 180. And these two on the side are consecutive, so these two would add up to be 180, and these two would add up to be 180 also. So you've got 4 sets of consecutive angles right next to each other that would have to add up to be 180. So that's the trait, I guess, about parallelograms that gets forgotten a lot, is that the angles that are right next to each other make 180 degrees. And the last thing is that the diagonals bisect each other. Let's see if I can draw something here. Nope, it's not gonna let me draw. Nope, it's not gonna let me draw. Diagonal. So if you connect one corner from here to here and the other diagonal from here to here, those diagonals are going to split each other exactly into 2 equal pieces. So the diagonal that's going from here to here, he'll be split into 2 pieces that are exactly the same size. Same thing with this one. So the diagonals bisect each other. We'll go over this more again as we add rectangle, rhombus, square, all that stuff to it as well. So just make sure you put that down on your sheet of paper. This is kind of like your log of all of the chapter 6 stuff. So notes, I'm going to go through this really fast. All of the stuff that I just gave you is basically what these things are. So if a quadrilateral is a parallelogram, then the opposite sides are congruent. Those opposite sides are the same thing with this one. If a quadrilateral is a parallelogram, then the opposite sides or opposite angles are congruent. So these two match up and those two match up. Okay, this one talks about the consecutive angles. So x plus y here would add up to 180. X plus y here would add up to 180. X plus y here would add up to 180. And x plus y here would add up to 180. 6, we didn't talk about on the other side, but here's what it says. It says that if you have a parallelogram and you have that this is a 90-degree angle, then this one has to also be a 90 degree, and this one's a 90 degree, and this one's a 90 degree. Because if you have these two properties here, and I know that this is a 90 degree angle, I know the one opposite it is a 90 degree, so that makes L a 90 degree. Well, if those two are both 90 degrees, then this one plus this one has to add up to be 180. So then this one is a 90 degree, and then that one is a 90 degree also. So you can map it all the way around that all of those have to be 90 degree angles. Okay? All right, I'm going to go through this real fast. This is a parallelogram ABCD. It's like the bars on the side of a basketball hoop. They say the measure of angle A is 55. This right here is 55. AB, this length is 2.5, and then BC is 1 foot. So they want to know what the length of DC is. Okay, DC is this bottom side here. since this is a parallelogram, it should be exactly the same length as AB. So AB is 2.5, so DC is also 2.5. Okay, angle B is this little angle right here. The only angle that it gives me is the angle A is 55. So I'm thinking, well, is B also 55? No. B is going to follow this consecutive angles are supplementary because A and B are right next to each other. They're consecutive. So if A is 55, to figure out what B is, I'm going to take 180 and I'm going to subtract 55, and that is like 125 degrees. So angle B is 125. Then they ask for angle C. Now angle C is across from angle A, so that means it has to be the same as angle A, or it's consecutive with angle B. So we can do that again. Angle C is the same as angle A, so that one has to be 55 degrees also. Okay. These two down here, the first one we talked about already, is that the diagonals have to bisect each other. So these diagonals that are going straight across here, this BD that's going here, this length here is going to be exactly the same as this length here. In addition to that, this diagonal here, this little part of it is going to be the same length as this little part of it. Basically, P is like the midpoint for this line, and P is the midpoint for this line. So the diagonals bisect each other. That's what I mean by diagonals bisecting. And then 6-8 we didn't talk about on the other grid, but basically if you have a parallelogram and you draw one of the diagonals, doesn't matter which one you draw. They've drawn this one. You could draw this one if you wanted to, but they draw this one. That separates this parallelogram into two triangles that are exactly the same shape and size. Those two triangles are going to be completely congruent. So same shape, same size for both of those. All right, I'm going to answer this example 2, and then we'll save example 3 and 4 for tomorrow. So they want to know what x is. X is, let's see, 5x right here. QT is 5x, and that's going to have to be the same length as what angle R is. So you would say that 5x would have to be the same thing as not angle R, excuse me, length RS. 5x would have to be the same thing as 27. So if you divide by 5, x is going to be something like, I don't know, 5.4 maybe. No, yes, 5.4. So solving for x, that's setting those sides equal to each other. Solving for y, solving for y, y plus 4 is looking at this length right here, y plus 4. And then the 2y minus 5, that's this other length here. Well, we know that those two pieces are exactly the same length. This one here and this one here. So you would say 2y minus 5 is going to be the same as y plus 4. And then you would move the y's around, you would subtract the y and add the 5, and I think you would end up getting something like y equals 9. Is that right? Yes, y equals 9. Okay, for z, 3z is right here, and we want to know what that angle is right here. 95, I'm tempted to say that 3z has to be the same as 95, but it is not. 3z is actually going to be the same thing as 35 for a couple different reasons. 3z and 33 are alternate interior angles if you look at these two lines being parallel. So those two are alternate interior angles. Also, if you look at these triangles here, this big one here and this big one here, those two triangles are going to be congruent, and these angles are the ones that correspond to each other. So 3z has to be the same as 33, which makes z equal to 11. So there's that, all right? I'm not going to go through, since I can't type out or write or draw or do whatever very well. I'm not going to go through example 3 with you, or example 4. We'll maybe do that tomorrow, but go ahead and try to do the homework assignment as well as best as you can. Just remember these right here, and that will help you do that. So these are kind of this is kind of your little cheat sheet on parallelograms, on what is true and what is not true. So refer back to that, and you should be golden. On Google Classroom, I went ahead and put on there which problems you need to do from the handout. So make sure you're paying attention to that. Otherwise, you'll end up doing all of them when you don't have to. So there you go.